Hello, my friends. Today we're back and we're talking Azure SQL, digging deeper into deployment automation and security. And we'll even talk today a bit about strategic adoption of open source with DevOps and infrastructure as code guru, Ryan Arujo. So if you're looking to level up your DevOps game, great session for you today. Remember to get over to the GitHub repo and get the code samples. Let's get to it. And we are back with part 2 of our discussion around Azure SQL deployment and security. And we're joined again by DevOps guru, Ryan Arujo.
Thanks for having me back again, Pete.
Yeah, my pleasure. So Ryan, jump in and tell us what you've got for us today.
All right, so we're starting up again from and resuming where we left off from yesterday. And yesterday we deployed a resource group for a Azure SQL Server and an Azure SQL database. When we had finished creating these two resources, we went through the firewalls and virtual network section here, and through Cloud Shell, we had added a couple of firewall rules in here. One to allow public access to the Azure SQL Server, and then we had added Pete's public IP address to have access in here as well. Since we're starting a bit fresh today, that rule for Pete has been removed, and we're going to repeat the initial firewall rule we created yesterday. So to start off, I'm here on my Cloud Shell. I'm associated with the Azure subscription we are working with here, Visual Studio Ultimate. And to start, I'm going to run this first rule here to ensure that the public services, the Azure services can access the Azure SQL database here using this firewall rule. Then I'm going to add in Pete's public IP address from his home so he can access the firewall as needed. And I'll change one thing in here real quick so it's a little more readable. And so we've added this in, and we can flip back over to our SQL Server. And we'll see that our rule has been added for Pete. So, Pete,
so a couple of things here. Couple of things here, yeah. So you'll notice that Ryan has a random alpha string on the end of his server name, and he does that because Azure SQL requires that name is globally unique, which really means unique in the region, because the instance in each region is going to have an FQDN that's unique to the region. Hey, Ryan, if you don't mind, since we're talking about firewall rules, would you just click that last link I sent you over in the chat so we can have a look at how Azure SQL firewall rules work? So this is going to be of interest if you're an infrastructure as code person, or you're studying for the AZ 500 exam. You have two types of Azure SQL firewall rules. You have database level rules and server level rules, and it would pay to understand how these work from a practical sense and from an exam perspective. So we'll drop this link in the day 103 transcript, but you'll notice here the way the flow works if you have a combination of database level firewall rules and server level firewall rules. So all I need to match is either a database level rule or a server level rule. It's not, I wanted to just point out, it's not the tiered scenario that you might imagine. So one could envision on an exam that perhaps I might get a question that tests my knowledge of how those resource firewall rules work. And that was something that was added to the AZ 500 exam mid-summer. I think that came in July. So just park that in the back of your mind. And if you're if you're an infrastructure as code person, equally important that you sort out with your security team how you want to approach your firewall rules. All right, so you have given me access to your database.
Yeah, I have technically, to the SQL Server specifically. And now that we have added this rule in place here. We wanted to demonstrate next how we could actually upload a BACPAC file to our SQL database. To start that process off, we need to create a storage account to store the BACPAC file. So this is going to take a couple minutes to run, and the storage account will be created in our resource group 100 days-Azure DB. And the return values we should be getting from this command will be the provisioning state, which we hope is succeeded, and status of primary, if I remember correctly, should return a value of available. And there we go, succeeded and available. Let's check our resource group. We'll check it again in a minute. I'm confident it's in here. Just takes a minute longer to populate in the portal. Next, we need to create a container within our storage account. And it's went ahead and did it. It created it as true. We can go back into our resource group here. There's our storage account. Let's verify that our container does exist. Our container for our BACPAC files. Now,
so let's hey, Ryan, if we could for just a second, I think we're going to have some folks that are maybe new to that BACPAC concept. So Ryan's talking about a BACPAC file, and if you look on your screen right now, you'll see the acronym here. It's BACPAC. So that BACPAC file Ryan's talking about is a window. It's a file with a BACPAC extension that basically encapsulates the database's schema and its data. So primarily, you'll see BACPAC files used when we're moving a database from one server to another, if it's a migration or we're moving a copy of all of those items to just another environment to work with. So certainly it's got some development value. And Ryan, a couple of questions here. So you're working with this in Azure CLI. Can I use a BACPAC file in an ARM template as well?
Yes, you can. You can reference it in an ARM template. You would be able to do this with Azure PowerShell. You can even do this from a build pipeline if you wanted to. There is something else that I think we'll cover later, but you can indeed do this in multiple ways to get your BACPAC into your SQL server or SQL database.
Yeah, no, Brian. So Ryan, on that note, so we're talking about a BACPAC file here. So this is your database schema and your data. Now there's another concept you're going to hear about, folks, and that's a DACPAC. It's a D like David, DACPAC, and that's a DACPAC is like a BACPAC file, but they're very similar, but they target different scenarios. So the DACPAC or the data tier app is going to be focused on capturing and deploying a schema, including upgrading an existing database. So that BACPAC is going to be great for moving database and data in a migration scenario. DACPAC is what we'll use in upgrade scenarios. So you might see this as often or even more often in your DevOps pipeline scenarios.
Indeed. Right, so now that we have our containers in place, we're going to pull down a sample BACPAC file from Microsoft directly from GitHub. We're going to use wget to retrieve that. And this will take just a second to download. And if we wanted to look at this file, we'll see it's a binary, essentially. So there's nothing here we can actually view with it. However, with, my goodness, I haven't used it in so long. I don't remember what the tool's called. Microsoft SQL, not Explorer. Pete,
we're talking about SQL Management Studio, or?
Yes, Management Studio or any other tool you use to manage a SQL database. You can browse and peruse through the actual BACPAC file. So again, our BACPAC, we have downloaded it now directly from GitHub. Now we need to upload it into our storage blob. upload it into our container in our storage account as a blob. We'll do that now. And it's in place. We're looking good here. Now that everything is in place, we need to import the BACPAC file directly into the SQL database. So I'm going to retrieve the primary storage account key from the storage account that the BACPAC file is currently stored in to ensure that this next command works. Because I'm going to be passing the storage key value to the AZ SQL DB import command to ensure this works.
And so Ryan just mentioned the storage key, folks. And so remember, from a security perspective, if we're thinking about our storage account keys versus SAS, using signatures instead, SAS is going to give us that high level of configurability. The key is going to give us essentially root access in perpetuity until we roll that key, right?
Correct. And we need to reset our SQL Server admin password right now, because again, since we're continuing from yesterday, we didn't store our SQL Server admin password in Key Vault or anywhere else, but you can find it in the video from yesterday. We need to quickly go through to our SQL Server and reset its admin password. So we'll do that right now. And let's put something in here, something that will work.
So while Ryan's resetting that password, two bits of good news here. So if you're studying for an exam and you really just want to get a database set up, so you're going to have access to all this code out there in GitHub, including a link over to that sample BACPAC file. But it's also possible to import a BACPAC file in the Azure portal. So if you look at your SQL Server, you'll find in the portal, it's on Ryan's screen right now, you'll see import database in his menu there. We can actually use that import database menu item to just import the file. So he's showing you the fancy way here that will facilitate automation in your scripting or your DevOps pipeline scenarios. But if you just wanted to set this critter up so you could explore for your study purposes, you can sure import that BACPAC file straight in through the portal.
All right, let's run our command again here.
All right.
This may take a couple minutes for the database to import fully.
Sure. Yeah, and when you look at that Azure SQL syntax, there's naturally a PowerShell equivalent to this. So we posted a plethora of PowerShell tutorial content yesterday. So in the show notes for this episode, you'll actually find a link to how to do this with PowerShell as well. Remembering that at least for your create commandlets that Azure CLI is idempotent. Now, in this case, we're importing a database, so that advantage of idempotence with Azure CLI doesn't really factor here anymore. So at this point, we're at a point of whichever you're more comfortable with. If it's PowerShell or Azure CLI or using the portal. So while we're waiting for that, Ryan, do you mind flipping over to the portal right quick?
Not at all.
So if you just look at your SQL Server, I want to just have you click on the import database option. There we go. So right there, folks, you can actually browse out to your BACPAC file, and you notice there it's looking for a storage account, so Ryan can browse to the same storage that he set up to facilitate that scripting scenario. So there you see how you would do that in the portal if scripting isn't really key to your use case, if you're just studying, for example.
Correct.
There you go.
But all the options that are available to you in here are available to you as well in the AZ SQL DB import command and the Azure PowerShell commandlet as well.
Yeah, there you go. So as Ryan mentioned, this takes a couple of minutes because the laws of physics apply, and there are a few operations, right? So that BACPAC file incorporates the database schema. So when he runs that, it's going to create the table structure, etc., and then populate the data. So how long that takes is going to also be proportional to how much data you're pulling in there and the complexity of the database schema, what your table structure, etc., actually looks like. But you'll find these sample backpacks, strewn about the internet, and it's great if you're trying to. Oh, look at that! Yeah.
Figured you'd like that. It is the 1%.
So now we're staring at the 1% held in such disdain here in America.
So bad.
So Ryan, let's talk about security while this import operation is going on here. So in terms of security yesterday, we talked about security from an authentication perspective. So you've got a SQL security and you have Azure AD security.
Correct.
So how does this vary? How does security vary in terms of securing access to the database itself? Do we get to a point that Azure SQL works just like an on-prem database from a security perspective?
Yes. So you have the option to configure security at the database level in and of itself with local users. And if I remember correctly, you also have the option to use AAD authentication to the databases themselves as well. So you have multiple layers of how you can configure authentication into your SQL databases running in Azure.
So again, this is really a dual purpose concept here, folks. If you're an infrastructure as code person working with your dev teams, on your CI/CD pipeline, sorting out the most secure strategy where you're incorporating Azure AD everywhere you can is going to be a great idea. For the security exams for the AZ500 in particular, understanding the support for Azure AD in the Azure SQL context is going to be important. That shows up on domain 2 and 3 of that exam, I think, are the two areas where you could likely see something. And then you'll notice Ryan's looking at the connection string there, which is typically what your devs are going to throw in their app config files.
Correct, for an initial setup and configuration on how they're going to configure everything up for them. So
yeah,
you have. Go ahead.
Go ahead. Sorry.
I was going to say you have just about it. You have a plethora of options available to you. So just about any scenario should be covered for you for your developers when they need access to this to authenticate to the SQL Server using programmatic strings. Go ahead, Pete.
And here, for both our DevOps and our security audiences, here's another Azure AD tidbit to park in the back of your mind, and that's around Azure SQL and Azure Kubernetes Service. So AKS shows up on your DevOps exams and your AZ500 security exam, and you can actually configure Azure AD authentication at the pod level in AKS. So Ryan, refresh my memory. I think that Azure AD pod level authentication is maybe a module that Microsoft open sourced, yeah?
Yes. They've open sourced it. It is available, it is stable, but it is not officially supported. So that would be the one gotcha you need to be aware of when bringing up the idea of using it in your environment if of course the discussion comes up with your boss or upper management. It works very well, but it is not supported at this time.
So Ryan, let me ask you a question there. You're a big developer in the open source world. How do you kind of evaluate which open source? So you mentioned open source and unsupported, and the great thing about an open source solution is the community can update it, and the downside is sometimes the community abandons. So what's your bar for am I going to use this open source component in a production solution? How do you come to a decision?
Yeah, typically it depends who I'm working with as well. If I'm working with a team of individuals that are very comfortable with open source products to begin with, that's the first thing. You want to make sure that you're not the only person trying to support this by yourself, right? Second, check on the commits of the actual product on GitHub or wherever it's being hosted. Most open source solutions you can find on GitHub. If an official version of a product is no longer supported, but there's a fork of it that has a lot of activity, say a lot of commits in the past few months or few days or few weeks, you can track the health of that solution on GitHub, and you can also track where they are planning to take the product in the future. So these are the things I like to keep an eye out for. I also keep an eye out for the complexity of the solution I'm looking to implement. Let's take an example, actually, while we're still waiting on this. Mm-hmm. And what was this product called? This actually came up. This came up in a chat I had today with my cohorts. It's in regards to Microsoft Azure notebooks. Mm-hmm. So, and GitHub. Here we go. So we were looking at this for a while, okay? Mm-hmm. And we were looking at a solution that was customized that works similar to Azure notebooks that use Jupyter notebooks instead, for instance. And we were discussing amongst ourselves, like, wouldn't this be a good idea to have a solution, a custom solution for this? Because at the time we were looking at Azure notebooks, our solution worked, but we saw Microsoft was putting effort and traction behind their solution, for instance, right? And I don't remember if this is open source or not, completely open source or not. I'd have to go look at the licensing on this. Mm-hmm. But what's interesting to note is there haven't been a lot of major updates in a long time. There's 1 to 4 months ago, but you can see not much else has been touched in several years. You can see in there, right? There's not a lot of activity. And so, all right, maybe at launch, this is a good idea to look at maybe putting in place initially in testing, but long term, we can see that it didn't pan out. Microsoft decided to go to a different route. Now, if we're looking at something for Kubernetes, let's look at something that is very active, that's not going anywhere, that a lot of people want to use, and that is Istio for controlling traffic and integration and security into their case clusters. We can see in here, this particular product, we have updates as of minutes ago, hours ago, days ago. It's very active. We have a lot of different issues that are opened up for it. We have a lot of pull requests. We have a lot of activity that people that are watching it, that are starring it. And then in the official website for Istio, a lot of these products have a timeline of how they're going to develop the product short and long term, and what their plans are, and how you can plan for the future, and how you need to implement and upgrade your solution long term, especially when they start making breaking changes that they plan for 4 or 5 iterations of the product going forward. So you're not looking at just one thing to determine whether you want to use something that's open source or not. You're looking at several different factors and then taking them into account with the team of people you're working with in the environment you're working in. So
Ryan has just perfectly articulated this, and I wanted to ask him because this is exactly what I expected. So he's looking, number one, to see if the solution is gaining traction, right? So the thing about open source is the likelihood of a solution being maintained in the long term by the broader community and the original publishers is directly proportional to its uptake. So in this case, if you look at the repo here, you can see almost 25,000 stars, 4,000 forks. And when we look at issues and pull requests, we can see are the issues being answered, or the pull requests still frequent. So he's looking at uptake. He's thinking about lifecycle management. So you heard Ryan mention, I'm looking at complexity and my team's ability to maintain our solution relative to what we're deploying here. So he's being careful to not take on technical debt that hampers the team's agility. Because the goal of DevOps, right, is to deploy frequently. And if we put something in the way that frequently breaks or requires a lot of work to upgrade across versions, we then sort of kill our agility, which breaks one of the prime directives of a CI/CD strategy in the first place.
Correct. So one last thing I want to point out here is that when you view the issues, for instance, under Istio, we see there are almost 1,000 issues open. But to get an idea of how involved the community is and how much the company that owns Istio is investing in their product, look how many of these pull requests, or excuse me, these issues were closed. It's 10,500 plus. So they are very active in maintaining and ensuring that this product is going to perform as advertised.
Yeah, it's super important. And at the end of the day, if you look at a service like Azure Kubernetes service, I think the official support documentation more or less outlines that you're supported right up to the point of about a hello world container, more or less, right? Or hello world pod.
Pretty much the services, as long as they're coming online and a pod starts up, AK or Microsoft right now cannot guarantee how do you correctly? They cannot guarantee that your application is going to work in Kubernetes. They can only guarantee that if your application is showing up as up and running in a pod, they can guarantee it up to that point. Because of the logic of your apps, something else may determine whether the app is not working correctly, but Kubernetes will be fine running the pod and the container within that pod and seeing that everything is working as intended. So
yeah, and I wanted to bring that up because that kind of speaks to my willingness to use open source components, right? So if I'm kind of on my own at the application layer anyway, it's not a crisis if I'm using open source components that aren't supported by Microsoft, because I'm not. I suspect you're never calling Microsoft support to get help with your apps running in AKS, are you?
No, you call the developer. You kindly put a call into the developer and ask politely, what the heck is going on? What did you do, good sir or ma'am?
There was such a PG way to put that, Ryan, and in a PC way to put that.
This is that type of show, mister.
There you go.
Real quick, I'm going to check on our import. It is still running. This is taking significantly longer than expected, but okay. Let's do a refresh. I want to see if for our info here, why does it still say at 1%? Okay, well, the good thing is, Pete, you can cut whatever you need to here at some point, or have fast forwarding across the screen.
Yeah, well, so if we get if we get to the end of the deployment there, yeah, I can fast forward the video reel to the end if we like. For sure.
Yeah, exactly. They'll make people sit here for 10, 12 more minutes.
In fact, it's been running so long, it just threw a reminder there that it's still running. Is that what happened?
No. I was hitting the return key, and so when it goes to its next cycle, that's the cursor runs the next cycle. That's why it's still saying running.
Gotcha.
I don't know why it would take this long. I think it would be good to point out, though.
Ryan, why don't I come back later and I'll just grab a shot of that when it's done, and we can take a look at that then. That's not really a crisis.
Sure.
So So what else did we want to talk about in this installment? We've covered a lot of ground already.
Covered ground we didn't expect to cover.
Indeed. That is the bonus that comes with organically structured talks like this one. It's coffee talk.
One thing I want to point out:
databases. No big whoop.
I do want to point out that we know that our process is still in progress and working, because we have the DTU is pegged out at 99% right now. So the compute utilization is almost 100% trying to run this import command. So it's not for naught.
Yeah, so a good point there, right? So our cloud mirrors real life in the data center here, because if we're running a smaller SKU of our Azure SQL, we're gonna peg that processing as we import a lot of data. So laws of physics still apply here, folks. You're gonna get the compute power you pay for under the hood. So that sucker's gonna take a bit to run.
Right now we're paying for a Ford Gremlin because we're going with something small, nothing special, something very economic.
Yeah, there you go. So that's running like a compact car because that's what we're paying for. That's fair enough.
Yep.
Well, Ryan, unless there's anything else, I think we'll wrap this up, and we'll grab a screenshot when that database finishes deploying, and we'll tack that on the end here for everybody to see.
Perfect.
Well, wow. So this was enlightening and surprising in a few areas. We got some nice real world advice here around not just security, but your thoughts on open source adoption. So thank you again, man. We're going to do this a third and a fourth and a 30th and a 40th time. Do me a favor, pull up your GitHub repo for the 100 days of infrastructure as code. So I want to just show you folks, when we talk about is something seeing traffic. So take us to your README if you don't mind.
Sure.
So we're going to go to the 100 days of infrastructure as code in Azure. So with this now the 103rd day, if you look in, so here's Ryan's README file, but if you look at the upper right-hand corner of his screen here, you see he's got, looks like his 300th star today. We've got 83 forks. So there's a lot of ongoing activity, folks. So make sure that not only, yeah, go ahead.
He means we actually, folks. Pete and several other professionals that we work with have been contributing to this. So this isn't coming from one person. This is coming from a very cool community of peeps. Pete, go ahead.
Fair statement. So Ryan and I are kind of 45 partners in this, and then we've got some folks that jump in for guest spots for sure, which is great. But as you see, a lot of forks, a lot of watches. So make sure that you follow us on YouTube, so you get a notice every time we drop a new video, because we're going to be dropping some videos in what we're calling 100 more days of infrastructure as code. Because you'll notice on Ryan's table of contents here, we're just about to post day 103 with this video. So this started out as 100 days, and we kind of revived this in an updated format. But you've got a lot of source code out here, and we'll be bringing a lot of content just like this that's video based, so you can listen on your phone or wherever you might be. So Ryan, remind us where we can find you on social media, and I'll throw those accounts up on the screen.
Absolutely. You can find me on LinkedIn. Just search for me, and also on Twitter at REIRUJO.
All right. Well, thanks again, and we'll look forward to seeing you in the next installment of the 100 More Days series, Ryan.
Absolutely. As always. Thank you for having me, Pete.
Yeah, my pleasure. And that's it for day 103. Be sure to reach out and let us know if you have any ideas for future installments. Be sure to subscribe, give us a like, and check out the 100 Days GitHub repo. Thanks for watching. See you in the next video.